Okay, what if I said this? What if I said like 2 plus 5 equals 7? Pretty easy, right? Okay, what I want you to do though is I want you to see some relationships here. If I have two numbers and it adds up to be another number, right? I want to compare 2 to 7 and I want to compare 5 to 7. What do you think you can say about 2 compared to 7 and then 5 compared to 7? Yeah, I probably didn't word it very well, did I? What we're going to do is, I'll just tell you what we're going to do today, and then this might help a little bit. We're going to talk about inequalities. What do you think about when I say inequality? They're not equal. Okay, that's what the in part means, and the equality means equal, so it's not equal. Okay, so if it's not equal, if one number is not equal to another, for instance, if I said 7 is not equal to 10, would you agree with that? All right, but you can also say something else. Have another comparison between 7 and 10. You could say that if it's not equal to 10, it must be what? What do you think? They're not equal to each other. So 7 is what to 10? I think I worded that fine. It's not equal to it. It's less than, right? It's just smaller, right? It's less. Less than 10. That didn't occur to you? No? Maybe I didn't word it right. I don't know. But you could say 7 is less than 10. Would you agree? That's an inequality. So let's go back to this. If I have two numbers and they add up to be a third number right here, what do you think I can say? What relationship could I say is there between like 2 and 7? I could say that 2 is what to 7? What's the comparison? What's the relationship? You could say that 2 is less than 7, couldn't you? All right. You could also say something about 5. What else? What could you say about 5? 5 is also less than 7. Would you agree? All right. Here's an example I gave in my last class, and I hadn't thought of this example in the past. It just popped in my head, but I think it worked pretty good. Let's say I had some money, right? If you want to think of it as $2 and $5. Let's say I got $7 in my pocket, right? I got it in my hand, right? I got some of it in one hand, I got some of it in the other hand, right? I give John $2, right? And I give Lauren $5. But I started off with 7. So it doesn't matter how I split it up. Both of them, either one of them, are going to get, if I give John some and I give Lauren some, right? I'm not just like giving Lauren everything, okay? I'm giving John some, I'm giving Lauren some. So what must be true about the money that they have compared to the money that I originally started with? They must have what? Did they have more money than I have? Do they have the same amount of money that I started with, or what? Yeah. I know you weren't. You said it, but let's try it one more time so everybody hears it. Look, I have $7. I thought I would make this easy by going money, but you're still not paying attention, are you? Okay, I got $7, and that's probably all I have in my wallet right now, but I'm not giving it away. Sorry. All right, it's not that important for me to give away $7 for you to understand this. Okay, but just pretend. So I have $7. They're all ones, right? I give you a handful, and I give Lauren a handful. Got it? So, in relationship to what I had originally, what do you have compared to what I had? You have less than I had, right? It doesn't matter how much money I have. I could have $1 million and I can give you some and I can give you some. You are always going to have what in comparison to what I originally started with? Less. Would you agree? So if I have two things that add up, right, to be something bigger, right? We're assuming they're all positive numbers here, not negative numbers. It would be a little different if it was negative, okay? But if I had two numbers that add up to be this third number right here, each one of those numbers right here has to be less than 7. Would you agree? Yeah. It doesn't matter what it adds up to be. Those numbers that are adding up have to individually be less than what they add up to. Get it? It's a pretty easy concept, isn't it? You say, well, how does that have anything to do with geometry? Well, I'm glad you asked that question. Very good question. Let's do this. You did? I know you did. That's what I figured. I knew you were thinking it, so I figured I'd just say it. With that said, look at this picture right here. We've seen this picture before. This is nothing new, but we're going to do a little bit of review on this, and then we're going to see how what I just talked about has anything to do with geometry. All right? By the way, let's name these. Let's just call this angle A, angle B, and angle C. Is that all right? And I'll tell you what, we'll call this point right here D. All right. So let's take a look. Look at this angle DAB. See this big old angle out here? Now, what did I say? I said out here, right? Because it's what to the triangle? It's outside the triangle, isn't it? Okay? Everybody getting this? Anybody paying attention to me? What's going on today? My third period class was like this. I don't understand why. I want you riveted, okay? I want you paying attention. I want you to learn this stuff, okay? Everybody's heads down, writing stuff. I want you to look up here. There hasn't been that much to write so far. Look at this angle right here. This is outside the triangle, just like Anthony said. Well, we gave it a name. What was the little bit of a fancier name? Just a little bit fancier than outside. The exterior angle, right? We called this the exterior angle. And we called all the angles inside the triangle, what did we call them? Interior angles. Very good. Easy vocab, isn't it? Now, what about B and C, though? We gave it a specific name. They're interior angles, but they're farther away from this exterior angle than this one right here. So what name did we give them? Remote, not exterior, interior, because they're inside the triangle, right? So they're not exterior, they're remote what? Interior angles. Remember that? Yes? Yeah. Okay. I want to know that you're alive. Okay, I know we just had lunch and all that kind of stuff, but let's stay awake. So this angle right here is a remote interior angle, and so is this one right here. What did we learn about that? Like, if I said that this is angle 1, this is angle 2, this is angle 3. Somebody was saying it. What? Who's saying it? Jada, you said it. What do they do? That's right. So 2 and 3 will add up to be angle 1. Exactly right. So let's write that down. So angle 1 must equal angle 2 plus angle 3. Everybody see that? You understand that so far, don't you?
Yeah.
Now, this kind of looks like what we started talking about earlier, right? With the $7 and the $2 and $5 thing. Look at this. What then do you think I can say about angle 2 in relationship or compared to angle 1? What do you think I can say about the measure of this angle compared to this one? Say it, John. It's less than. That's right. So angle 2. If angle 2 plus angle 3 are equal to angle 1, what do you think I can say? I could say that angle 2 must be what? Less than which one? Without even looking at the picture. Without even looking at the picture, I can just look at this thing right here. What can I say about angle 2? Angle 2 must be what to angle 1? Must be less than angle 1. This is less than. Sometimes that kind of looks like a angle symbol. All right, just be careful. Maybe make it a little bit bigger or something just to make it stand out so it doesn't accidentally look like an angle symbol. All right, but this is, so angle 2 must be less than angle 1. What else could you say about this situation? Angle 3 has got to be less than angle 1 as well. Everybody see that? So just looking at this picture, I didn't give you any values whatsoever, did I? I didn't tell you what angle 1 was equal to. I didn't tell you what angle 2 or angle 3, what the measures of those angles actually were. All I did was draw this triangle, extended one of the sides, and I can say without knowing any of these degree at all, I know that angle 2 is going to be smaller than angle 1. And I know for a fact that angle 3 is going to be smaller than angle 1. Why? Because I know that they add up, right? Angle 2 and angle 3 add up to be angle 1, so individually they must be less than angle 1. It's like the money thing, right? $2, $5, this is $7. These have to be smaller than the $7. Does that make any sense? So you can make that comparison with the angles and the money and all that kind of stuff, right? It's pretty simple, isn't it? What if I did this? Let's make it a little more complicated. I didn't do this in the third period class, so you guys get a little extra benefit here. You're going to see a problem that looks kind of like this. Now that looks the same, doesn't it? But I'm going to slide another, let's do like that. Alright? And let's label, I almost said able, let's label some of the angles. Call that 1, 2, 3, 4, 5, 6, and 7. This is a little bit of a simplified version of what you're going to have to do on the worksheet. All right? What they're going to do is they're going to say, take a look at angle 1 and tell me all the angles that are less than angle 1. I didn't give you any values, right? It's not 3 degrees, 4 degrees. It's just the name of the angle. So I didn't tell you this is 30 degrees, this is 60 degrees, this is 90 degrees. I didn't say any of that stuff. Just by looking at this picture, you should be able to figure out. And it's not just by what they look like. You don't just look at the angles and say, well, it looks like that angle is smaller. All right? I want you to know for a fact, why is it smaller? So we're taking a look at angle 1. So name all the angles that are less than angle 1. All right, well, let's think about it. What did we just learn? We learned about the remote interior angles, didn't we? All right, so look at this. Just look at this triangle right here. Everybody see this triangle right here? This angle 1 is an exterior angle, isn't it? What angles are the remote interior angles to this triangle right here? 3 and 5. So what do you think I can say? I can say that 3 is what? Less than 1. And I can also say that 5 is less than 1. So let's write angle 3 and angle 5 in there. Is that it? Is that all that we can say?
No.
This is also an exterior angle to something else. Let's draw this in a different color. What else is this an exterior angle to? Not just angle 3, but what? Is it just angle 4? Nah, this angle 1 doesn't really have any relationship just to this triangle right here. But watch. What if I talked about that whole entire big triangle? You see it? See the whole entire triangle? That would be a remote interior angle, wouldn't it? All right. Forget this one that goes down the middle here, okay? Picture it without that line. What else is a remote interior angle? 7 is. That's right. This angle right here. Everybody see that? So this angle right here is a remote interior angle to angle 1. And this angle right here, angle 7, is a remote interior angle to angle 1. So guess what must be true about this whole big angle? It's got to be what to angle 1? It's got to be less than. So if both of these added together is less than 1, then 3 must be less than 1, which we already said earlier. And what else must be less than 1? 4 has got to be less than 1 as well. So I can add that to my little list. What else do you think is less than angle 1? Angle 7. Why? Because 7 is a remote interior angle to the exterior angle 1. Everybody see that? So 7 must be less than angle 1 as well. Can I say that about angle 6? Is angle 6 a remote interior angle to angle 1? It's not at all. There's no way. All right, because look, you only got the 2 triangles. Well, you actually got 3 triangles, but to this exterior angle, you only have 2 triangles. You've got this one right here. Everybody see it? With the 3, 2, and the 5. And then you got the big one, right? The 3, 4 combination, the 2, and the 7. So that's the exterior angle with all those. So those are all the angles that are less than angle 1. And how did we know that? Did we look at it and just say, well, it looks like it's less than it? Did we do that? No. Because we know that, watch, angle 1 is equal to what? Angle 3 plus angle 5. Agreed? Because 3 and 5 are remote interior angles to angle 1. So that means that 3 is less than 1 and 5 is less than 1. But we also know this, that angle 1 is equal to this whole thing. What's this whole thing? Angle 3 plus angle 4. Would you agree? And what's the other remote interior angle to the whole big triangle? Angle 7 is. So watch, if all 3 of these add up to be angle 1, what must be true about all 3 of these? What's the relationship between all 3 of these and angle 1? They all have to be smaller, don't they? Yeah. So that means angle 3 has to be smaller than 1. Well, we already set it up there, though, didn't we? And then 4 has got to be smaller than 1. And then 7 has got to be smaller than 1. Is that making sense at all? Yeah, I think it does. I think I did a pretty good job explaining it, to tell you the truth. All right, I think it's pretty clear. If it's not, go back and watch it again. Sometimes just hearing the same exact thing 2 or 3 times makes sense. All right, I've done that before. Have you ever watched a TV show or a movie or something like that, and you watch it a second or a third time, even a third or fourth time, and you're like, I didn't see that the first 3 times I watched that movie. You ever do that before? Yeah, I do that all the time. I'm watching something, man, I don't remember that ever happening, or I don't remember her saying that or him saying that. You know, why? Because you don't catch everything the first time you hear it, do you? All right, if you hear it 2, 3, 4 times, then you have a tendency to catch on to stuff that you didn't hear the first time. All right, it works on TV shows and movies and songs, right? You hear a song for the first time. You don't remember all the words that they said, but you hear it 5, 6, 7, 8, 9, 20 times. You start remembering what all the words are, and then you hear different things in the words, right? Would you agree? Have you had that experience? Yeah. Well, the same thing holds true with learning. All right. You hear it 2 or 3 times, and you're way more what's the word? I don't know. You're gonna remember it more. Okay, put it that way. I don't know where I was going with that phrase, but you're gonna remember it more. So watch this a couple more times, and it'll make sense to you. Okay, I promise. You just gotta try. You just gotta really sit and think about what's going on, and you gotta write the stuff down, and you gotta stop and pause it, concentrate on what we just went over. All right. So enough of that. Let's go on to something a little bit different, but kind of the same. Let's make a triangle again. And watch this. This is pretty interesting. It seems like we always make a cute triangle. So let's be a little different. Is that all right? And make a cool looking obtuse triangle. How's that? Isn't that lovely? All right. Yay, obtuse. All right. There we go. It's triangle ABC. Let's just, I'm just going to make up some numbers here. Let's say that's 10. Let's say, I don't know, that's 5. And let's say that's 7. All right. Here's a rule. A theorem is basically what they tell you. All right. This is a theorem 5, 9, and 5, 10. I don't really care about the numbers. I wouldn't know what the numbers were. They just call it 5, 9, and 5, 10 because it's chapter 5. It's the 9th theorem and the 10th theorem that they discussed. All right. Other books, they'll number them differently, so I don't care what the numbers are. But here's basically what it says. What you're doing is you're going to compare the sides. Now, they tell you the sides on this problem. You're going to compare the sides with the angles. So which side is the largest side on this triangle? AB, right? Because it's 10. Which one is the smallest side? Talk to me. AC, right, because it's 5. Which one is the one in the middle? BC or CB, right, because it's 7. Everybody with me on that? Now watch this. This is pretty interesting. I'm not really going to say why. I'm just going to show you that it's actually true. Okay, we could sit there and change these triangles around all we want, and it's always going to work. It doesn't just work for an obtuse. Works for any triangle whatsoever. All right, look at this 10 right here. That's the largest side. Would you agree? Which angle does it look like? Now, I usually tell you don't just go by the looks of the triangle, but in this case you can. What angle looks like it's the largest angle of the whole entire triangle? C. A? Looks larger than C? Right. C is the obtuse angle, right? Obtuse angle has to be the largest angle of all, right? Because it's greater than 90. So look at the relationship. Look where 10 is compared to angle C. They're what to each other? They're not perpendicular. There's no right angles there. I can't say they're perpendicular. They're just what? We've used this word before. They're what to each other? If I said here and I said go to the opposite, right, angle or whatever, all right? If you were here, what's the opposite angle? What's opposite to this side? This angle. Would you agree? Just go across from it. It's opposite. Yeah, we've done that before. That's not new. You guys are looking at me like I'm speaking another language here. We've talked about this, okay? A side is opposite this angle. What's opposite side 7? What angle is opposite side 7? A, angle A. Okay, what angle is opposite side 5? It would be angle B, wouldn't it? All right, so do you know which ones are opposite now? You got to make sure that you know that, because if you don't know that, then you're going to be sunk on this stuff. So know which ones are opposite which. Now, look at this angle. This is the largest angle because it's opposite the what? The largest side, thank you. All right, this is the largest angle, all right, because it's opposite the largest side. Everybody see that? So what do you think would be true about angle B? What do you think I could say about angle B? If angle C is the largest angle, what do you think is true about angle B?
It's the smallest.
How do you know it's the smallest? Just because it looks like it?
Because it's opposite of 5.
That's right. It's opposite the 5, which is the smallest side. You seeing that? It's not that hard to figure out. Look, that's the smallest side, and where do I look? I look to the opposite angle. If this is the smallest side, this has to be the smallest angle. If this is the biggest angle, the side opposite has to be the biggest side, or the other way around too, right? If this is the biggest side, then C has to be the biggest angle. So which one's the medium angle then? Angle A, right, because it's opposite what? The medium side, right? It's the best way I can think of describing that, the one that's in between, right? The smallest and the biggest. You got it? So here's what they're going to do. Let's get rid of all these lines and all that good stuff. Let's get rid of that, get rid of this, get rid of that, all this mess. And we'll just go by what we started with right here. So here's what they're going to ask you to do. They're going to ask you to list, in this case, all the angles from smallest, what do you think, to largest. And this is what they give you. They give you all three sides, all right? And they ask you, okay, if I give you a triangle and I give you the lengths of all three sides of the triangle, you should just be able to look at it without even, guessing how many degrees they are. You should be able to tell me which angle, right? We're doing angles. Which angle is the smallest, which is the medium, and which is the largest. So let's do it one more time. So how would I list this out? What is the smallest angle in this triangle? It's B. Why is it B? Because it's opposite the smallest side. So what do? You look for the side first, don't you? The smallest side. And where is opposite? It's angle B. So angle B is the smallest angle. All right? What's the next largest one? Okay, the middle one. The middle angle. Well, you look for the middle side, don't you? Okay, so the middle side is here, and you look opposite that, which is angle A. So angle A would be the middle angle. You know what I mean by middle angle, right? It's not the smallest, not the largest. So now, there's only one more left, so that's pretty easy. But you can look at the numbers and make sure that works. What's the largest angle? Well, you look for the largest side. The largest side is 10, so you look opposite 10, and angle C has got to be the largest angle. Make sense? Of course, it's the only one left, so you had no other choice, did you? But it makes good sense that that works. Now, they're going to give it to you the other way, too. What else? How else do you think they could ask you this question? Well, they could go largest to smallest.
Excuse the interruption.
I think.
Will Dr. Cheadle please come to or call the upper school office? Thank you.
I think, though, I haven't gone through every single problem, but I'm pretty sure every time they ask you this question, it seems like, don't hold me to it, but it seems like they always go from the smallest to the largest, okay? So, but always read it, though. Just make sure that I'm not wrong. They could say go from largest to smallest, but if I'm right, I think that they go from the smallest to the largest. But what did I give you first, though? I gave you the what? On the picture, I gave you the what first? What was given?
The sides.
The sides. I gave you all the sides, didn't I? Okay, so if I gave you all the sides on that one, what do you think I could do in this problem? I could probably give you all the what? Give you all the angles, right? So let's do that. Let's say, I don't know, let's say that skinny one right there is 20. Let's say that's about 30. So that's what? And let's just stay right there, okay? What if that's all I gave you? And then I ask you to not list the angles from the smallest to largest. What do you think I'm going to ask you this time? The sides, right. So this time, let's list the sides from the smallest to the largest. Well, look, they only give you two angles right here. But we can always find what? The third, right? Josh, get your head up, please. So look at this. 20 and 30 is 50. Take 50 away from 180. So what's this angle C down here? It's 130, isn't it? All right, so now we got all our angles. Now it should be easy. Now, it's the same triangle, so, I mean, this shouldn't be real difficult because you already know which one is the biggest, which one's the smallest. But let's do it anyway. So we're going to go from smallest to largest. So where do we look here? We look for the smallest what first? Smallest angle. So 20 degrees is the smallest angle, so which one is the smallest side? AC. Good. So I write AC, line segment AC. What's the medium one? Well, you look for the medium angle, right? Which is 30. What's opposite 30 degrees? This one right here, which is BC. So that would go next. And now we look for the largest one. Which is the largest angle here? It's this one right here, isn't it? So what side is opposite the largest angle? It's AB. And then I'm done. Pretty easy stuff, don't you think? Yeah. So they call this inequalities in one triangle. So we just want to find, what's smallest, what's medium, what's biggest. That's what they mean by the inequalities. We got that? I don't think there's anything else. I think that's pretty much what they give you. All right, and you got about 12 minutes left in here. That's good news, isn't it? Now you can do some work. So I'm going to give you a worksheet on this. It's section 5.3. I think it's page 63, I believe. Okay. All right, so I'm giving you this worksheet now. Finish it up and try hard, okay? You've got about 10 minutes or so in here, 10 to 12 minutes, so work hard on it. Try to get most of this done if you can. The hardest part of this worksheet is this thing right here. Hopefully you took notes on that and that makes a little sense to you. It goes a little bit beyond this. It's a little bit tougher than this, but it's very, very close to this thing right here. Okay? All right, good luck.